Okay, this is going to be the video for Tuesday, and this is basically going to be the second part of our discussion of queues. Okay, so let me share my screen here from my iPad. So again, we talked about the idea of a queue, and this is in the other video, but we have this idea of we have a front, we have a back to a queue. That's for the array. We'll talk about what it is. But in general, it's going to be, well, losing my mind here. Here's the operations. We need this is from the ADT, right? So we have our initialized queue is empty queue is full queue, the front, the back, the add queue, the delete queue. Okay. So when we're looking at the idea of a linked list, okay, so an empty queue just points to null. But once we have an item, okay, so if our queue is in here, then we can determine how we're going to add things. Okay, so we're going to have an array or a pointer, not an array. We have to have a pointer to both the beginning and the end here. Okay, so the elements are going to be added at one end at the rear and removed from the other end. So we're going to have to know the front of the queue and the rear of the queue. So we need 2 pointers there. Okay, so otherwise, I mean, when we add one, we can add one at the head, we can add one at the rear. The implementation doesn't matter, and I don't know what the book's going to do. We can look at that as we go along. But that's basically the idea. Whichever one we pick, we're going to be able to do things like that. Okay. Again, we're just like before. We're going to have those 2 positions available. So let's go ahead and look now at the actual code, and we'll talk about how the code differs. Okay. And again, for this one, you're going to want to go through and type the code yourself rather than cut and paste. I think it just makes the most sense. Okay. So again, this one we're going to call this linked queue type, just to keep us straight. Okay. So again, just like before, we're going to have our node here. So we have our template, class type, and just so we're clear on this, type is just a variable name. We can call it whatever, but don't think more than you have to. There's no reason to change the name of that. You keep it that name, everybody knows what you're talking about. So we're going to create our struct node type for our linked list. Okay, with this one, we're going to have a type for the info, just like we had before. Have a node type pointer, node type pointer called link. Okay, so all that's pretty much as we've had before. Then we're going to have template class type. You do need this every time. It gets used very locally. Linked queue type, which is going to inherit in public fashion from the queue type ADT or whatever type we're dealing with. Okay. So again, I want to look at the end first into the private. And this is going to look very similar to the linked list version of the stack. Okay. So we're going to have a node type, so a pointer to a node type of type. It's confusing. For the queue front. And we're going to have another node type of type that points to the queue rear. Okay. There's no concept of a maximum size. There's always a maximum size, and then if we run out of memory, we're going to be out of memory, but we shouldn't have to worry about that for a while. Okay. So again, I'm not going to do all these, but this is going to be very similar to what we had before. Okay, we're going to need the is empty queue, is full queue, the initialized queue, the front, the back, the add queue, the delete queue. Okay, we're also going to need the default constructor, the copy constructor, the destructor, and to overload the equals operator. Okay, so all that again, that's on page, in my book at least, 464. Okay. What I do want to look at though is some of the functionality here. Okay, so this first one here is going to be on the is empty queue. Okay, so again, we're going to do a template class type. You may be asking yourself, would you ever not do a template class type? I can't really think of a reason not to. It doesn't take much and allows so much flexibility. Linked queue type. So we have to namespace it. And this is the is empty queue. Okay. It's a constant function. And on this, all we're going to do is return if the queue front is equal to null. Okay. If you don't have an equal sign in there, it either won't work or it will always be true. So those, you got to watch it, double equals. Okay. So that's all we care about. Okay. As far as the is full queue, it's going to return false every time. We need it to be there for the ADT. It's got to be a thing, but we don't have to, it doesn't have to ever have a value. Okay. So let's look at the initialized queue, see what it's going to look like. Okay. So again, we have our template class type. This is going to be a void function. Home keys are useful. I can't find the keys at all. Linked queue type. That's our namespace for this. Initialize queue. Okay. So for this one, we have to first create, we've seen this before, a node type node called temp. Okay. I'm going to initialize that. Then we're going to say while queue front is not equal to null. Okay. So again, to initialize, we're assuming here. So let's talk about the game plan here. There's assuming that the list has something in it, or the stack, the queue has some elements in its linked list. We have to go through each one. We're going to save it or copy it to the temp, basically, because we've already redone the assignment operator. Then we're going to delete that. So that's going to go to each element in turn and let us get rid of everything. Okay. So we're going to let our temp be equal to the queue front. Okay. Then we're going to make queue front follow along to the next one by equal to queue front link, like we did on the linked list implementation of the stack, very similar. Okay. Then we're going to delete temp. Okay. We're going to do that and deallocate the memory for all of the elements of the existing queue. We're going to have a queue rear is now set to null. And we're done. Okay. Pretty straightforward there. Okay. So for the add queue, let's look at that one. I'm going to go ahead and copy some of this because I'm tired of typing this. Okay, so all that's going to be similar here, but this one's going to be it's a void function. But this one's add queue. Add queue. Okay, it's going to take a constant address of a type called new element. So we're passing the reference in essence. Okay. So again, we have to create our node type. This is the same idea we've done before with linked lists. We're creating our new node. Again, you can call it whatever you want, but why not call it new node? We always do. Okay, then we're going to let the new node be equal to a new node type. Okay. So the new keyword is going to actually allocate that. Okay. So we've created a pointer here. Now we're creating this actual element in memory that we can point to. Okay. And then after that, we have to go ahead and populate that new node. Okay. So we have to let the new node info is going to be equal to that new element that we're sending in as a parameter. Okay. And then the new node link is going to be equal to null. Okay. So this is just out in memory somewhere, but now we have to worry about how we're going to hook it up. Okay. So if we're pointing, if there's no link list, okay, then we're just gonna have to set the queue front and queue rear both to this new node. So if it's already empty, okay. If not, we're just gonna have to set the queue rear link to this new node and then make the queue rear follow it to the next link, okay. So we'll do this with an if statement. So we've got if the queue front is equal to null. Okay, so it's at the moment empty. We're going to let the queue front be equal to this new node. Only has one element, so that's also the queue rear. Else, so else it's not empty, that there is something there. We're going to let the queue rear link. Okay, so what the end of the link points to is now going to point to the new node. Okay, so we've slipped that in as the new end. Okay, and now that queue rear, should be a rear, queue rear itself pointer is going to be equal to the queue rear link. Okay, which is also going to be new node, I mean, by the way, because we decided to be that. Okay, so that's going to take care of the constructor, or sorry, the add queue. Okay, so the front and the back, all of that, some of those are in there, some of them are going to ask you to do yourself. Okay, so we then get to example 8.1, which the program is going to test operations on the queue, and it's going to use the class linked queue type to implement the queue. Okay, that's going to create a new one and go through the adding and deleting from the queue. Okay, so once you get things working, you should definitely test that out. Okay, there's also a small section here at the end of the chapter on deriving from the class unordered link list, which you certainly can do. It doesn't mention it for much. That's one of the homework exercises that I probably am not going to give. We'll have to see what that looks like. Okay. Then there's also the standard template library class queue, the queue container adapter. Okay. And there's some information there about what it does as far as the operations that it has. It has a size, an empty, a push, a front, a back, and a pop. Okay. And that's really about all. So you can look at that if you want. We're not going to do a lot with the standard template library. It's kind of its own thing. Okay. So the very last thing that we talk about, and it's an interesting one, and it's worth spending a little more time on. And there's quite the example here that you can look at. It's good to know. You don't have to implement it unless you're struggling a bit. And that's the idea of a priority queue. Okay, so it's often the case that we in general want to go in line from first in to the first out, but sometimes there are higher priorities. Okay, so an example could be if you're at a hospital and you know you're going to be waiting in line because you broke your toe or whatever. Okay, if somebody comes in that's been in a car wreck or they're having a heart attack or whatever, then they're going to go higher in line. Okay, so that's the idea of a priority queue, and a priority queue basically defines some criteria for ranking which cases are the most important, usually numerically. Okay, so if ones go before twos, go before threes, go before fours, and so forth. You could make it the reverse if you wanted. But with a priority queue, you're in essence going to keep multiple queues. Okay, so everyone goes from Q1 before they do for Q2. Okay, so there's the standard template library class priority queue that they're going to look at in this next example. Okay, so it's this simulation here where we're going to physically monitor, or we're going to simulate some system using this queuing system. And this is on page 472 and 473. And it's interesting stuff. In this case, we're going to have a server, we're going to have a customer, we're going to have some transaction time about what's going to happen. Okay. So it's going to go through this example. Again, this is an interesting example that I'm not going to go through, and you don't have to go through, but it's interesting stuff. The idea of the customer, it starts on page 474. Okay. Then we go through and model the server, which is useful, and then the server list. Okay, so we're going to serve the different customers based on their priority level. Okay, there's going to be the waiting customers queue. Then there's the main program. Okay, this is an interesting one. It talks about when the customers arrive and when they actually get what they need from the server and move on. Okay, so that's a good system. That's a good program. In fact, that's something we may work on for lab this week. I'm not sure yet, but keep that in mind. It's worth looking at, okay? But it won't be part of the homework per se, okay? But again, priority queues are important. It's important to understand how those work, and that's a good way to do that, okay? So that's it for chapter 8 on queues. This was a two-parter. Make sure you listen to the first part first, okay? So this is the video that should be for Tuesday, okay? So the problem set should be out there by the time you watch this, so you should be able to go through and work on the homework as we go along. And again, if you have questions, make sure you send me a text and I will get back to you at some point. Okay. So that's all I've got for this time. So the next video will be on the next chapter. We're covering a lot this week on searching and hashing algorithms. Okay. So that will be coming up. Should be out there already, but that will be for the Wednesday lecture.